Okay guys, so welcome back again. So in this video, let's see that why should we not use simple secrets or rather the same secret to sign our JWTs and verify our JSON Web Tokens. But instead we should be using public and private key pair. That is, the private key is used to sign the JWT and the public key is used to verify the authenticity of the JWT. So basically when you use a simple secret, that is the same secret to sign and verify a JWT, it uses a symmetric signing algorithm, and whenever you use public and private key pair, then it uses asymmetric signing algorithm, because we would be using the private key to sign the JWT, and to verify the JWT we would be using the public key. And the public private key would be an Rsa key pair. And don't worry if you don't understand that what I mean, because I'll be explaining each and every step in detail that how do you implement it. But before that, I would be going through a couple of slides and let's see that what is the problem of using the symmetric algorithm, and then we'll be seeing that what are the benefits of using the asymmetric algorithm, that is the RS256, when signing and verifying our JWTs. And then later on we'll be diving into our code and we'll implement this asymmetric algorithm to sign and verify the JWT. So firstly, let's have a look at this slide where we have these microservices. So firstly, we have this auth service, which is responsible to sign the JWTs, that is to generate a JWT and send it back to the client. And then we have a couple of more services here. That is the MS service, which is again authenticated. That is, whenever we want to make a request to this MS service, we should be sending a JWT along with the request. That is maybe inside the authorization header as the bearer token or with the cookies. So it doesn't matter that how you are sending token to the service, that is whether it's in cookie or whether it's in the authorization header. And in the similar way, we have this resource API service, which is again an authenticated service, and to make request to this service, we also need to send a JWT along with the request. So what happens here is this, that inside our auth service, which is running in its own server, uses some kind of a secret here. And that same secret has to be present on these two services also. That is the MS service and the resource API service. And that is the major drawback of using a symmetric signing algorithm. That is using the same secret to sign the JWT and to verify the JWT. Because as you all know that JWTs are not opaque, it is only a base64 URL encoded string and anyone can read what's inside them. So these secrets are not for encryption. The only use of secrets is to verify the signature of the JWT, which ensures that whether the token is tampered or not. So the problem with this approach is that we need to share the secrets between different services, since to verify the JWT, we also need this secret which is used to sign that JWT. And this is one of the major drawbacks of using a symmetric algorithm like HS256, because it uses the same secret to sign and verify the JWT. Another problem of using this secret is this, that whenever you want to change the secret key to sign the JWT, you need to change that secret at each and every instance of each of your resource services, because then only that JWT can be verified with the new secret. So suppose if you change the secret here at the auth service, then accordingly at the MS service also you need to change the secret, which should be the same secret as this, as well as on the resource API service you would be changing the secret, which is same as the secret. So now suppose one of these services, that is either the MS service or the resource API service, is compromised. Even if one of them is compromised, then our secret is out and open. Anyone can use that secret key to sign the JWT, and that JWT would be valid for the other service. So as soon as the secret key is compromised, that is this API service is compromised, then what you need to do, we need to change the secret key at each and every instance. That is, we need to change the secret at this auth service, we need to change the secret at this MS service, and we need to change the secret at this resource API service itself. And it takes time, and by then the whole application data might be leaked in that time. Moreover, it might be a case that you even don't know that this service is compromised. So what will happen in that case is that on your behalf, using the secret key, any person can sign JWTs using the same secret, because that is the secret which we used initially to sign the JWT, and that JWT would be valid at each of your services. And lastly, there is one more drawback, and that is client-side verification of the JWT is not possible, since you cannot keep your secret keys on the client side, because it is a secret and the client shouldn't have access to that. So in that case, if you want to verify the JWT on the client side, then you have to make a request to the auth service just to ensure the validity of the JWT. So now let's go to the next slide, and before going to the solution, if you want to go through the problem once again, you can pause here and you can read all about it. So it's the same thing which I talked in the previous slide. So now the solution is to do authentication using RSA, that is the public and private key pair. So let's have a look at the diagram here. So here we are using RS-256. Don't worry about this. I'll be doing all that in code and you would be getting to know that how it is all done. Don't be overwhelmed by this. So here again we have all the three services, that is the auth service, the MS service and the resource service. So since we have a public and private key pair at the auth service, so what will happen is this, that as soon as a user makes a login request or the register request, a JSON web token would be signed with a private key, and this private key is confined to this auth service only. No one else has the access to this private key. So what will happen is this, that the JSON web token is signed with the private key and it is sent back to the client. And now whenever a client makes a request to any of the resource services, that is either this resource API service or this MS service, so he will send the JWT along with the request in the same way as he was doing before, as the bearer token in the authorization header or inside the cookies. It doesn't matter. He just needs to send that JWT along with the request to the service. And now this MS service or this resource service does not have access to this private key. What access they have? They have access to the public key. So there are two possibilities. One is that you can keep the public key at each of these instances, that is the MS service or the resource service, and you can verify it. But that is not the proper way of doing stuff, because again, in case you want to change the public key or the public private key pair, then you have to change the public key at each and every instance. But instead, what we'll be using is something called a Json Web Key Set. That is, as soon as a token is arrived at this place, that is MS service, this MS service would make a request to the auth service to get the public key from the auth service itself. And that from that public key, this JSON Web token, which is coming here, would be verified. And if the verification is successful, a response would be sent. And now you might be wondering that every time a JSON Web token is coming to this MS service, we are going to make a request to this auth service for this public key. It is not the case, because what we can do, we can cache this public key for a particular period of time. That is, we are not going to make a request to this auth service to get the public key again and again, but this public key would be cached to this MS service. And as soon as the JWT came here, the cached public key would be used to verify the authenticity of that JWT. So let's have a look at how does a private key look like. So it is a simple RSA private key, and it is very short here because I have omitted some characters here, but it's a long private key here. And the public key would be looking something like this. And then this is what I'm talking about, that is a Json Web Key Set. So this whole is a Json Web Key Set, and it contains this thing here, that is this keys object here, which is an array of Json Web Keys. So this is an individual Json Web Key, and this whole is a Json Web Key Set. So this is what we are going to do in this video. That is, we'll be creating our Json Web Key Sets using the public key. And this key, that is this Json Web Key, contains only the public part of the RSA key pair. So without wasting any more time, let's dive into the code and let's see that how all it is implemented. Okay, so here what I'm going to do, I'm going to create two microservices. One is the auth service and the second one would be this resource service. And as you can see that I have opened VS Code, though you can use any text editor, but I prefer to use VS Code. And here what I've done is that I've created this empty directory called resource service. And thus in the same way, I've created this directory that is called auth service, and pretty much it is also empty. There is nothing inside this directory also. So the first thing which I need to do is to initialize an express application in both the directories, because they would be two express applications. That is, the auth service would be an express application and the resource service would also be an express application. And to quickly scaffold the express application, I'm going to use this package that is called express draft, so that I can simply do exp dot to initialize a new express application. So let's do it. So here inside this auth service, I simply need to do exp dot, and now it will simply initialize a new express application inside this folder that is called auth service. And while it is doing so, let me go to this other service also, that is a resource service, and I'll also initialize a new express application here. That would be simply exp dot to initialize a new express application inside this folder. That is an empty folder here. So let me do exp dot here also, and here we also have this express application ready to use. So let's go to the auth service first, and here what I need to do, I need to run my auth service on port 4000. So let me quickly change the port inside the .env file to port 4000. so that our auth service would be running on port 4000 and our resource service, that is this service, would be running on this port, that is port 3000. And now to distinguish between these applications, let me just change the color for this application. So let it be Next.js blue color here, and for this application let me change the color to something called red. So let me use Angular red here. So now the red application denotes our auth service, and this blue application will denote our resource API service. So now firstly let's work with the auth service, because there we are going to generate our JSON Web Tokens. So let's go back here to our auth service, and here what I need to do, let me create one more directory here which would contain our RSA public keys and the private keys. So for that, what I'm going to do, I'm going to create a new folder inside this folder that would be called certs. Though you can name this folder as in what you like, but I prefer to call it certs. So firstly, to generate Rsa keys, what we need to use something called OpenSSL, and it is by default installed on Mac. For Windows, you can check out the documentation of OpenSSL, that how to install it there. And for Linux, I guess that it is also pre-installed, but you can search about how to install OpenSSL on Windows or Linux, and it would be super simple to do. So now let me simply generate an Rsa key by using this OpenSSL. So we'll say OpenSSL, and here we'll say gen RSA to generate a Rsa key. And here I would like to output it inside a file called private.pem, not public.pem, but it should be private.pem. It would be a PEM file, and then I would need to provide in the key length of the Rsa key. And here I am going to provide in 3072, and that is 3072 bits key. Though the minimum standard for generating Rsa keys is 2048, but here I am going to use 3072, and you can use 4096 also to make it more secure, but that would take some time to generate. So I would be using 3072, and this is pretty much secure. So now let me simply press enter, and it would generate an Rsa key here inside this private.pem. And instead this file should be created inside the certs folder. So let me quickly move this file, that is private.pem, to this certs folder. And now we have this file, that is private.pem, inside the cert folder. And if we open this file, we see that we have this key here. This is the private key. And now let me quickly generate the public key of this private key. So let me clear out the console and let me cd into the certs folder, so that we do not have to move the key again. And now we are inside the certs folder, and here now I would like to create a public key from this private key. So I would say OpenSSL RSA, and here I would provide in the input, and the input would be the private key. So I would say private.pem, because we are in the same folder, that is the certs folder, and this key resides in the certs folder. And then we would say pub out, which means that we want to get the public key out of from this private key, and here we provide in pub out, and then in which file we want to output it to, we want to output it inside the public.pem file. So we'll say public.pem. So we see that writing is done, and now we have the public key also of this private key. So if we have a look here, we see that this is the public key. So now let me go back to my root folder here, that is the auth service, and let me clear out the console. And now if I open my app.js file, here we have a very super simple Express application, as we see that is generated by Express Draft package that I initially showed you, that is this package. So because of this, we have our Express application already scaffolded here with all the defaults here, or basically all the de facto Express packages which you might be using inside your Express application. And here we have one route, that is the index route, and here we have the API route, which we might use or we might not use. But here in this tutorial, I'm not going to use this API route. I'm simply going to use the index route to mimic a login route. So now let me simply start this application and let me see that if this application is working or not. So let me simply do npm run dev, and it will basically run this application in development mode with nodemon. So it is started on localhost port 4000. So if we go to localhost port 4000, so let me go to this port 4000. So we see that here we get a message that is awesome, it works. So we know that this application is running also. And let me also quickly check this application, that is the resource API application. So here I would also do npm run dev. And here this application is started on port 3000. So let me open this file, and here it also says awesome, it works. So we see that our resource API service, or the resource service, is also working on port 3000, and the auth service is working on port 4000, as we can see. So let's go back to our auth service. So let me go back to our auth service. So where is it? So here is the auth service. So here what I need to do, I need to make a login route here, and here I'm not going to use MongoDB or any other database to register a user and sign up a user and then make the user login. But instead what I'm going to do, I'm simply going to say login here. That is, I want to create only a single route here that says login, and here we would be simply signing our JWT with this private key, and we would be sending it back to the client, and we wouldn't be making any checks whether the user is registered or not, though in a typical application you should be doing all that. And here I'm considering that you have done all the checks, and here I'm simply going to respond back with a JSON Web Token. So here what we need to do, we need to install a couple of packages here. So firstly we need to install JSON Web Token here inside this auth service. So let me stop this application and let me do npm i JSON Web Token just to create web tokens. So now we can use this package, that is JSON Web Token. So we'll say const JWT equal to require JSON Web Token like this. And now we'll go to this login route, that is this route, and here let me make a comment, that is, I am assuming that you do all the login checks. And let me write something else also, that is, and then only issue a JWT. No, that is, you should always do whatever login checks are there inside your application, and then only you issue a JWT. But here I am assuming that you have already done that, and I am simply going to issue a JWT here. So what I'll say const token equal to JWT, that is the library we imported, JWT.sign. And here what we need to sign, the payload. So for the payload, I'm going to simply provide an empty string here, or an empty object here for the payload, and then we need to provide in the secret. So let's say the secret is this secret, which is not currently defined. And here are the options. So here for the options, I simply provide in expires in, let's say 10 minutes, like this, because this JSON Web Token library takes expires in time in this string also. So I can provide in 10 minutes here. So again, what I need to do, I need to provide the secret here. And since we are not using symmetric algorithm, so we cannot use a simple secret here. And for that, what I'm going to use, I'm going to use this private key here. That is the RSA private key to sign our JSON Web Tokens. So to read this file, that is private.pem, what I need to have, we need to require the file system module. So we'll say const fs equal to require fs. And this fs module is baked inside Node.js, so we can directly use it. Or a better module would be to use fs extra, because that provides the async approach also without the callbacks. So that would be an extra thing if you want to do. But here I am simply going to use the synchronous version using this file system module. So here what I'll say const secret equal to fs.read file sync, and here we need to provide in the path, and I am going to directly provide in the path like this, that is /certs dot and /certs and /private.pem, simply like this. And now we can use this secret to sign this token. So what we can do, we can instead of sending back this message, that is awesome, it works, we would be sending a JSON object here that would say token, and then we can simply pass in the token that we have created here. And since we are using modern JavaScript, so if both the things are same, then I can simply omit this second thing here, and it would be sent like this. So now let me save this, and before saving it, there is one problem here, and that is was intentional in my part. That is, whenever you are using public and private key, you need to define the algorithm of the JSON Web Tokens. If you would have used a simple plain secret here, then this would have worked fine. But since we want to use public and private key, so we need to define the algorithm for this JSON Web Token. So for that, what I'm going to do, I'm going to simply say algorithm, and here I would be saying RS256. Simply like this. So now let me save this, and now the token that would be generated using this algorithm, that is RS256. And you might be wondering that while generating the RSA key, we use 3072, which is 384 bytes, and here I am using RS256. And this 256 in this rs256 simply means the SHA hash function which we are using, and we are using SHA-256 here. So therefore it is called 256, rs256. Though the private key that was generated here is of 384 bytes, that is 3072 bits. So don't be confused about this. That is why I'm using rs256 here and not rs384 here. So that is one thing you should remember. And now if we go to our login route, we should be getting back a token here. So now let me simply do npm run dev to start the application. And now let's go to our URL here, that is port 4000/login. And typically you would be making a post request to this route, that is the login route, with the username and the password, or the email and the password, and only then you would be getting back the token. But here I am simply making a get request here. So let me enter here, and we see that we get back this token here. That is this long token here. So what I can do, I can copy this token from here, and let me copy it in my clipboard. And I simply want to show you one thing. So let me open here jwt.io, and let me paste this token here. So let me paste this token here, and if this works. So now let me remove this token from here, and let me paste our token here inside this thing here. And now we see that this token has an algorithm of rs256 that was provided by us. And here we see that to verify a signature, we need to provide the public key also and the private key also. And if it was signed using the symmetric algorithm, that is HS256, then you would be simply need to provide a secret here. So this is only for demonstration, that is we have created a token that is signed with public and private keys. So now let's get back to our application. And now here we have the auth service ready, but there are a couple of things which is needed to be done here, that is converting this public key to the Json Web Key Set format, and we would be doing that in a moment. But first let's simply switch on to our resource service, that is the resource API service, and this is running on port 3000. So let me open its app.js file, and for the index route we can see that we have this thing message, that is awesome, it works. But here let me simply change this message, that is this is a resource API routes, or whatever it is, just to make it distinguish it from the auth service. And here I'm going to create one more route that would be called that would be a protected route, that is this would be a protected route, not protected but protected route. And here we can see that this is a protected route like this, and you can only access this route if you have a valid JWT sent to this application or to this route here. So to provide a route, what I can do, I can or to make request to this route, what we can do, we can either use Postman, or what I prefer to use this extension here that is called REST client. So I can say REST client. So I have a dedicated video about how to use this REST client. So it is super simple to use, and we can make requests to any of the routes using this REST client. So for that, what I'm going to do, I'm going to create one file here that would be called rest.http. So let me create a file here, that is rest.http. And now let me simply start the application again so that it is always running in the background. And let me go to open this file, that is rest.http, and here I want to make a GET request to http://localhost ports 3000, because our resource service is running on port 3000. And here I want to make a request to this route. So if we do this, we see that we get this message, that is this is a resource API route. And let me again create one more route here, and this would go to this protected route. So if we make a request here, we see that we are getting a message back that this is a protected route, but we want to protect this route with a JSON web token, which we have got from our this thing here, that is from the login route inside the auth service. So we can use this token here. So let me copy this token once again. So let's go back to our resource service, and here to this protected route, I want to send in the JWT token along with the request as the auth header. So we'll say authorization, and we want to send it as a bearer token. So bearer and then the token itself. So even now if we make a request, it is a protected route, but we want to protect this route somehow. So let's go to our app.js file, and we want to make this route protected. So what we can do, we can use an express middleware. So that is called express JWT. So let me stop this application and let me install in a package here that is express JWT. So let me do npm I express JWT, and basically this package that is express JWT verifies the bearer token inside the authorization header. So that is the reason I'm going to use this package here. So let me do npm start or npm run dev again. So now it is again started, and now let me require this package at the very top. So we'll say const express JWT equal to require express JWT. And now what I'll do, I'll use this express JWT as a middleware here. So I'll say app.use express JWT and then here I would need to provide in an object here, and the object would contain the secret that is the secret to verify the token, and I would be putting in that secret in a moment. And if you would have used a symmetric key, that is the same secret to sign the token and to verify the token, then you can simply provide in that secret here. But we are not going to do that. We want to get our secret from the auth service itself. So I've just kept it empty as of now, and we would be doing something here to get the secret in a moment. And then we need to provide in the algorithms here, that is which algorithms are used here inside this token. And here I can again say RS256. And now inside this resource service, we want to keep this index route open. That is, it doesn't require authorization, but all the other routes require authorization. So to make this route not protected, what we can do, we can use something like this here. That is, after this thing, we can simply say .unless, and here we can provide in the path here. So path. And here we can provide in an array of paths, so we can simply say /. That is, this route is not protected and all the other routes inside this application are protected. And now if I save this application, we get an error and it says that secret should be set. So for now, let me simply set a secret called 123 and it should be up and running. And if we go to this res.http and if we make a request to our index route, we are getting back the response. But if we make a request to this protected route, we see that we are not getting a response back. Instead, we are getting a 401 unauthorized error. So this is something which we already expected, because we have not yet verified the token with the correct secret, because this secret is like is simply a placeholder here. We need to provide in the secret from the public key. So there are two ways to provide the public key. Either you can copy this public key from your auth service, that is this file here, and you can paste this file here inside this resource service, and in any n number of resource services which are using the same JWT or the JWT issued from the auth service. And then you can simply use the FS module to verify the token by reading that public key from individual resource services. But here what I'm going to do, I'm going to use something called JWKS, that is Json Web Key Sets. But to generate a Json Web Key Set, what we need to do, we need to go back to our auth service again. So let's again go back to our auth service. So here what we need to do, we have this public.pem file, that is this RSA public key. So we need to generate a JSON web key from this public key. So let me install one more package here, and that would be RSA pem to JWK. So I would say npm I, and the package name is RSA pem to JWK. That is to convert the pem file to JSON Web Key Set. So let me install this package and it would take a couple of seconds. And now let me create one more file, that would be convert pem to jwk.js, like this. And now let me simply go to this file here, that is convert pem to jwk. And here what we need to do, we need to again require the fs module, because we want to read the private key. So we can say require fs, like this, and then we require the package, that is rsa pem to jwk, and this should be equal to again require, and here it would be rsa pem to jwk, like this. And now the first thing which we need to do, we need to copy we need to read the private key, because we have generated this public.pem file from this private key. So we use the same private key to generate the public JSON web key. So we'll say const private key, not key but key, like this, and it would be fs.readFileSync And here again, we need to provide in the path. So we can simply say certs /private.pem like this. And now we can say const JWK would be equal to RSA pem to JWK, that is this package. And here we need to provide in the private key. So private key is this private key, which we have read here. And then we can provide in some extra keys here. And we want to use this JSON Web Key to verify the signature of the JSON Web Token. So we can provide in one option here, that is use sig, which means that this key, that is this JSON Web Key, is used to verify the signature of the token. So that is why I'm putting in this property here, that is use as signature or use as signature verification. And then the JSON Web Key can contain the private part also and the public part also, but we are interested in only the public part here, not the private part. And this is most important here. So what you can provide here, you can simply provide here public. That is to get only the public key inside the JSON Web Key. So we would do it like this. And finally, what I'm going to do, I'm going to make a log statement here, that is console.log JWK like this. And now let me save this. And now what I'm going to do, I'm simply going to execute this file, that is convert pem to JWK by using node here. So let me clear out the console here, and maybe let me increase the font size, which I forgot initially. So now what I'll do, I'll simply say const convert pem to JWK, and let me press enter. And now here we see that we get this object here, and this is a JSON Web Key. So let me copy this file from here, or let me copy this object from here, and we are going to paste it somewhere. And where we are going to paste it? We are going to paste it inside the public folder. So let's go to our app.js, and here firstly what we need to do, we need to define our public folder, and there is no public folder inside our auth service. So let me create one public folder here. So let me create a public folder by doing makedir public. And now we have this public folder here. And now inside this folder, what you need to do, and this is a convention what I am doing here, though you can directly create a file called JWKS.JSON inside this public folder, but by convention, you should be creating a folder inside this public folder called .wellknown. So let me create that folder, that is .wellknown like this. And now inside this .wellknown folder, I'm going to create a file here, and that would be called JWKS.JSON like this. And now inside this JWKS.JSON, we would be having an object here, which would be having a key called keys, and this would be an array of JSON Web Key. And here we can provide in the JSON Web Key, which we have just generated. And this should be in double quotes like this to make it a valid JSON object. And now here, let me copy this JSON Web Key, which we have generated here. So let me copy it. And now inside this keys folder, let me paste it. So let me save this application. And now let me simply do npm run dev. And now what we can do, we can go to this URL, that is, let me show it to you. So let's open another tab here, or let me open this tab here. So localhost port 4000 /.wellknown, because that is a folder inside our public folder. So I can do directly .wellknown, and then we want to use this file here, that is JWKS.JSON. And if everything went well, we should not be getting this error here. And why is it so? So let's go back here. And let's go to our app.js, and we are getting that 404 or 404 error because we have not defined our public folder here inside our app.js. So for that, let's use a public folder here. So we can say app.use express.static, and here we can simply say, and here we can simply provide in public, simply like this. And it would by default take in the public folder to be the static folder here. So now if I save this file here, and if we go back and if we reload the page, we see that we are getting back this file here, that is JWKS.JSON. And since it is a public key, that is this JSON Web Key contains only the public part of your RSA key. So this can be read by anyone in the cloud. So now what we can do, we can use this JSON Web Key, that is the public RSA key of our private key. We can use this key to verify this token, which we are sending here to this route, as a secret here. That is, here we have simply provided in a placeholder that is 1 to 3. So here we would be using that secret. So how to get that secret? So it is, so for that we need to again use one more package here, and that would be called JWKS-RSA. So we need to install one package here that is called npm JWKS-RSA, and it has to be used inside your resource services. So let me install this package, and it would again take a couple of seconds. So again, let me npm run dev to start the application, because I want my application to be running always. So let me again increase the font size here. So now I'll require that package here. We will say const JWKS client, if I can spell it correctly, equal to require JWKS-RSA, like this. And now to provide in the secret here, we can use this client, that is this JWKS client. So we will say JWKS client dot express JWT secret, and that is a function here or a method here. And here we can provide in some options. So the first option would be JWKS URI. So what do you think that the URI would be? The URI would be the public key that is provided by our auth service. So we can copy this link here, that is localhost port 4000.wellknown/jwks.json, and we can plug in that URI here. That is the path of the public key here. That is the path of the public key of the private RSA key. And now, as I've told you before in the slides, that we can do caching here. So we can simply say cache to be true, that is to cache the JSON Web Key that is returned from this path or this URI. So it would be cached, and by default I suppose that this is cached for some time. You can read more about that in the documentation of this JWKS client. But here we can simply say cache to be true, and here we can also say rate limit to be true. That is, this URI would not be would be rate limited. That is, you won't be able to make thousands of requests to this URI by this application. So we can say rate limit to be true, and if you don't understand, you can simply keep these values to be true, and you would be good to go. And now let me save this application. And now if we go to our rest.http, and if we want to make a request to this route, index route, so we see that this is a resource API route. So it was out and open because we did not protect this route because of this thing here. And now if we try to make a request to this protected route, which initially we were not able to do so, but this time hopefully if everything went fine, we should be getting a response back. That is this response here. That is, this is a protected route. So let's keep our fingers crossed, and let's try to click this button, that is send request. So we see that we get a message here that is JWT expired, and it means that our JWT thing is working, and the JWT is expired because it is like past 10 minutes since we issued this JWT token from our login route. That is, from this login route, we provided an expiration time of 10 minutes, and that by the time of recording this video, 10 minutes have already been elapsed. So what I'll do, I'll simply go to this login route once again, and we'll generate another JWT. So let's go to this login route here, and let me again simply press enter. And now we have another JWT here, which is signed with the private key or with the private RSA key. So let me copy this token, and let's go here to our resource API. And instead of this token, let me paste in the new token which we just copied here. And now if I make a request here, we see that we are getting this message that this is a protected route, which means that this token has been verified by this Express JWT using this package that is called Express JWT client, which uses our URI, that is the JWKS URI, to get the JSON Web Key from the Json Web Key Set that is provided inside this jwks.json file. And we are using public and private key authorization to verify and sign our JSON Web tokens. And no matter how many resource services you have, like this is one resource service, you might have another resource service in the similar fashion. And then you can simply use this logic here inside each of your resource services, that is inside each of your microservices, and then you would be verifying your JSON Web tokens in no time, and you would not be sharing your secrets in different microservices, because in this application we have only used the public part of the RSA private key to verify the token only. And this public key, that is the JSON Web Key, which is a public key inside this Json Web Key Set. Let me go once again here. That is, this whole is a Json Web Key Set, and it contains keys here, and in these keys we have an array, and here this part is a single public key, that is a JSON Web Key. So this whole is JWKS and this is JWK. So this contains only the public part, and this key cannot be used to sign a new JWT which is valid for this application or for this authorization service which we have created here, that is this authorization service. So guys, that's all about this video. So if you have liked the video, do give me a thumbs up, and if you haven't subscribed to the channel, do subscribe to the channel. So thank you, bye bye, tata, take care, and have a good day and have a great day.